Hi, welcome to the first tutorial for how to use the GenTact Toolbox. This is a tool for procedurally designing and fabricating whole body artificial skins for robots. The process is the same for any other object too that you want to design for, but in this case, we'll be focusing specifically on robots. This is going to be a two-part series. In this first part, I'm going to show you how to use the Blender procedural generation add-on to design your own skins in a very short amount of time. And then I'm going to show you how to fabricate a skin using 3D printing, and we'll deploy it on the real robot in part two. Uh, if you don't know what I'm talking about with GenTact Toolbox, I urge you to check out the link in the description. This is the website for it. It just recently came out. But yeah, let's get to it. So to install the add-on, first we need to make sure we have Blender. I have a fresh install of Blender 5.0.1 on my computer. Next, you can go download the procedural skins bundle from GenTact on their GitHub repository. In here, you'll find the latest release. So we're going to go ahead and click down on this zip file right here to download it. Then we will extract it somewhere that we will remember. So I'm going to extract it onto my home screen. And then we can get right into Blender. If this is your first time opening up Blender, this is the home page. To start a new file, you can click General right here. You're going to be greeted with a camera, basic cube, and a light. We don't need any of those, so we can hit A and delete to delete all that. If you have a model of your robot that you're going to use, you can use File, Import, STL, or whatever format you have. I will be using a file that I already pre-prepared using the Franca FR3 robot. Once you have the robot model loaded in, we can actually download the add-on by going to Edit, Preferences, File Paths. And out of the asset libraries, we're going to add the file that we just added to our desktop. It should say Procedural Skins add-on or whatever the recent version is. And now you have it. So you won't see anything yet, but to check that it worked, you can open up a new pane. Use this drop-down menu to open up the asset browser. And you should see a GenTact Toolbox catalog. If you click on it, these are the four main layers that we are going to be using to make our skin. So I'm going to focus on link 5 right here on this skin, on this panda. So I think I'm going to cover right over the surface here. So I'll drag and drop a dermis layer, which is the outer shell. It's a little big. And I am going to open up the modifiers tab right here. Turn down the thickness to about 0.01. There we go. There's the outer shell that we'll use. So if you think I'm cheating, it's because I am cheating. I already pre-specified where I wanted this skin to be. And the way I did that was using vertex groups. So each model, each mesh inside of Blender has data made out of vertices, edges, and faces. So you can actually assign a weight to each of these vertices, which is the fundamental premise of how this modifier pack works, how this procedural skin works. So we'll open up the data tab. You'll notice I have a dermis, nodes, and routing vertex groups. If you wanted to make your own, all you have to do is hit plus. We will call this tutorial dermis. I will turn off the current skin that I have by clicking this display modifier or the display button right here. And then I'll specify where I want to actually put the skin by using edit mode or weight paint. I prefer to use edit mode if I really want to get a fine-tuned, really precise skin, but weight paint works really good for just very quickly layering down where you want skin to be. So make sure that you're in the right vertex group. And then with the paint tool, drag over where you want the skin to be. So I'll do that as a start. Now, if I turn back on the skin, first I'll go to object mode. If I turn back on the skin and set the paint name to what my vertex group is, you'll notice that it follows right around kind of the heat map that I have. I can change the tolerance on that weight that I assigned using this slider. If you're unhappy with how it kind of turned out, you can just go back into weight paint mode. You don't even have to turn it off. Start painting live. For the purpose of this tutorial, I'm going to stick with the pre-made dermis vertex group that I made earlier. Okay, so now that we have our outer shell, we're going to want to add some sensors inside. Each of the sensors are composed of a nodule, which are a flat disc, that are wired to a clip that sits on the outside of the shell. So we'll start by adding the self-cap layer, which makes self-capacitance discs. We'll turn on X-ray mode so we can actually see the discs being displayed inside. Now, for the density paint, set this to the vertex group that you want to use. I already have one called node set, but we'll make another one just for demonstration purposes. I'll call it tutorial. Going back into the modifier tab, set this to tutorial nodes. You can start painting. And you probably will notice that you can't see anything. That's because in weight paint mode, you can't go into X-ray mode. Or in the weight paint tab, you can't use X-ray mode for the visuals. But fix this, just go back into object mode, see what you've done. Currently, nothing's showing up because I actually have the density set as too high or too sparse. Right now, it's 0.2 meters per nodule. I want that to be a little lower. So I'll do 0.04 meters per nodule. There we go. So again, weight paint mode, set your vertex group, and paint where you want the sensors to be. For this tutorial, I'll just use the one that I already have, the nodes weight paint, which looks like this. And then I'm going to find a configuration that I think looks good. So actually, this one turned out pretty well, but if I wanted a little bit different of a look, I can change the seat around. You know, this one actually is not too bad either. I kind of like the symmetry that this one has. So once you have your nodes, once you have your dermis layer, we can add the wiring layer. Now, this is probably going to be overwhelming at first to look at. So to simplify things, I'm going to clean this up a little bit. I'm going to turn off all the other links on the robot so that we can just look at the one sensor we're working with. I'm going to turn off this big nasty mesh by doing show routing layer. I'll turn that off. And I'll also disable include original geometry. So now we're just looking at our sensor. It's a little goofy, but what you'll notice is that there are wires that are going towards the centers of these nodules. They're a little offset, but they're connected to these cylinders, which will be our clips that will be sticking outside of the shell that will connect to with an Arduino or a microcontroller. So let's clean this up a bit. Let's go down to our wiring layer. And actually, let's start with our self-cap layer, and we will lower this wire intersect offset. I'm just going to bring this down like this until it intersects with my sensor. You'll notice in my case, it added this little extra cylinder inside each of the nodules when I lowered the wires to be intersecting with it. But those are the stems. The stems are initially included at the start, but you can disable them by adding this modifier as without stems. I'll keep the stems off for now. So another thing I can clean up is that these clips are a little nasty. If I look at what we'll actually be printing, they're way too big. They're sticking out way too far. I'm going to lower the radius by about, I think 0.004 is probably good. Make them not as long. Should be fine. You'll notice that the clips are pretty far separated from each other. I think where I want to actually have them on this skin is right here on this edge. So what we will do is lower the separation. Maybe about, that should be fine. And I'm going to set a target for them to try to be as close as possible to. So I want them to be on this edge right here. So I will make a new empty plane axis. This is going to be our target, so I'm going to rename it to target. Bring it as close as I can, just in that general side, I suppose, of where I want the clips to be. On the skin, I'll then scroll down to the clip reference, set that to be my clip target. And let's adjust that just a bit to be something like that. That looks perfect. Perfect on the part that I want to keep it on, but there definitely is some offsets and it's not quite in the right position. So what I will do is a little bit of fine tuning on the translation. On the motion. We rotate this a bit. That is about as good as I can expect. Great. All right, so you'll notice that some of the wires are kind of peeking outside from the top of the dermis and the bottom of the dermis. Now, the reason that this is happening is because our routing layer, which is the space that we're actually allowing these wires to travel in, is directed right, or it's located right at the edge of the inside and the outside of this dermis. So we'll show that layer. You can see all of the paths right on the top and the bottom. I'm going to set this to be one layer and put the offset a little bit higher so it's inside the skin. To see the wires, go into X-ray mode. I'm not going to spend too long tuning these wires up, but ideally we want them to not be overlapping and they should each be connecting into their own respective nodule. So I think one thing that I'm concerned about is that this nodule is just a little too big right here. It's kind of intersecting with the wires, so I'm going to adjust the nodules. I'm going to make them a little thinner. So I'll go to the node offset. This is based off of percentage of the dermis. So I maybe want it to be only 20% thick to increase depth to take care of this clipping that was happening here. And then I'll put this at 75% of the dermis. So that way there's about 5% of the dermis's thickness is on the outside. If I wanted to increase that, I could just lower the thickness. That looks good. That looks good. Yep, the wires are intersecting with nodules. They're not poking out too far. They all are non-overlapping and they're not touching each other. There might be a little bit of concern about crosstalk in these sections, but I'm not going to talk about that in this video yet. Okay, this is our skin. It's complete. Okay, so this is what our final skin looks like. Let's bring back the robot. So I'll start by including the original geometry it was applied to. This is the link. Then I will show the rest of the robot model. So this is what it looks like. This is what we can expect to see on the skin. As you probably could tell after watching this video, a lot of designing a sensor that works for you is customizing and just playing around with the numbers that are presented to you in this modifiers tab. Each section of the robot is going to be completely different shaped. So this whole process was designed to be agnostic to shape, but that requires a little bit of playing around with what it is you actually want. Some fun tips about this. If you have a skin on top of a mesh and then you scale it, what you're actually doing is setting the scale for both for the skin as well. So let me demonstrate that. I will make a new skin. And I'll put some sensors on it. Right, so watch, if I scale this down, you can see that the skin and the sensors scale down with it. But this can be problematic, especially if you're using custom sensor layer instead of the discs, because the sizing will change. And some of these, they say 0.2 meters, for example, that's going to be completely wrong. So what you can do is hit Control A and then apply the scale. And that will reset the scale of the skin to be in line with your scene's units. That concludes this tutorial. Thank you for watching. In the next one, when I get around to doing it, I'm going to print this sensor and deploy it on the real robot.